Hello people, we have a very exciting exponential equation in today's video. We have 2 raised by x times 8 raised by x is equal to 30. So how do we get the value of x? I have a very interesting number. I have some interesting numbers here. We have 2, we have 8. Do you know that I can express 8 as a power of 2? Of course I can. So it's going to be 2 raised by x times what? 8 can be expressed as 2 raised by 3 because 2 times 2 times 2 is what? 8. Why am I doing this? I want the left hand side to have the same base, so I can apply the law of indices. And I can just group this like this. I'm going to have x here. You see, if you multiply 3 by x, you get what? 3x from one of the laws of indices again. So I'm going to have 2 raised by x times 2 raised by what? 3 times x is what? 3x. And this is equal to what? 30. Let's now use the multiplication law of indices. If you have the same base as we have 2 and 2 here, we can in fact add the exponent x and 3x. So this is going to be 2 raised by x plus 3x. This is equal to what? 30. Are you still with me? Now this is going to be 2 raised by. Can I add x to 3x? Of course you can. So that's going to be what? 4x. And this is equal to 30. What is going to be the next thing? Now, because I need to get the value of x, I will have to take the logarithm of both sides. So I can have this 4x come down here using one of the laws of logarithms. So let us apply logarithm to both sides. So it's going to be log 2 raised by 4x is equal to what? Log 30. Are you with me? So what's it going to be now? From one of the laws of logarithm, let me just write it here. If you have log a raised by b, this can become what? B log a. So this b can become the coefficient of the logarithm. So it's going to be what? 4x log 2 is equal to what? Log 30. You see what I'm doing? Okay. So I'm going to have what now? Okay, we can divide both sides by log 2 because I'm looking for x right here. So let's divide both sides by log 2. So it's going to be 4x is equal to what? Log 30 over what? Log 2. Okay. So 4x is going to be, now look at this 30. I need to break it down to what? 2 times 15. You know I can do that, right? I'm going to have log 2 times 15, all right, over what? Log 2. Why am I using 2 times 15? Because I'll show you somewhere where we can cancel out now, because I have log 2 already here, so we can just cancel that out. So it's going to be 4x is equal to what? Log 2 plus log 15. From one of the laws of logarithm, if you have log a times b, this can become log a plus log b. This is the product law of logarithm. So that's what I did here. Notice this 2 times 5 now became what? Log 2, and then plus what? Log 15. All divided by what? Log 2. Now this will become 4x is equal to, do you know that I can divide log 2 with this log 2 and log 15 with log 2, because log 2 is actually dividing log 2 and log 15. So it's going to be log 2 over log 2 plus what? Log 15 over what? Log 2. Okay, see what's going to happen here. Log 2 cancels log 2. So 4x is equal to what? You know, we already have 1 here. If you divide, you have 1 plus what? See, let me also split log 15. So log 15 can be written as what? Log 5 times 3. Because in actual fact, 5 times 3 is what? 15. Okay, so it's going to be, again, I'm now going to bring back that law of logarithm where I have 5 times 3 become, where I have log 5 times 3 now become log 5 plus log 3. So it's going to be log 5 plus log 3. See this log 2, I'm going to use it to divide both log 5 and log 3. So what I'm going to have here will be over log 2 over what? Log 2. You see what I'm doing? I'm now going to use the change of base rule. But before I do that, see, this has a coefficient of 4. So I have to divide every single thing by 4. Okay? Maybe I should just use the change of logarithm, the change of base rule here, first of all. Okay, I hope you know from one of the laws of logarithm, if you have log a base c, I want to change this base to something that, let's say, to base x, is going to be log a base x over log, this base here will become a new argument in the denominator with the same base you are changing it to, so base what, x. This is how change of base rule works. So let's bring it in here now. It's going to see there's a base 10 here, base 10, but watch what I'm going to do. So this will be 4x is equal to 1 plus, I will now write log 5 base, I want to use this 2 here, erase base 2, because if you want to use change of base rule, you can change it from this to this, where you have a new base as 10. So this is what we call the change of base rule. I'm going to do the same thing with this one here. It's going to be what you tell me, log what, 3 base 2. If you use change of base rule, you can change it to this one as well. Again, the base here is what, 10. They have a base of 10 here, okay, and that is what we have. So let us look at this now. See what we have. 4x is equal to 1 plus log 5 base 2 plus log 3 base 2, but we need to get the value of x. So I'm going to divide both sides by 4. It's going to be x is equal to what, 1 plus log 5 base 2 plus log 3 base 2 all over 4. And this is the value of x that will satisfy the equation. But hold on, we need to test it whether it is really the value of x that will satisfy the equation. So let's go back to the equation that we had before, which is what? Let me just write it here again. So we're doing some tests. And the equation was what? 2 raised to power x times 8 raised to power x is equal to what? 30. Let's see if this will give us what we want. Remember that when we're doing this test here, when we started solving this, what we changed it to 2 raised to power 3. So let me just quickly do that so that I will have something much simpler to work with. I already told you how to do this from when I started this video. So this will be 2 raised to power x plus 3x, which is what? 4x, using the multiplication law of indices. So we want to see if this will give us what? 30. Let's test it out now. Remember, we already know that what? X is what? 4 is from here. What is the value of x that we got? Let's go check it here. 1 plus log 5 base 2 plus log 3 base 2. So let me just write it here. 1 plus log 5 base 2 plus what? Log 3 base 2 all over what? 4. Okay, so let's see if this will give us 30 on the right hand side. Now 4, we cancel 4, and then I just have 2 raised by what? 1 plus log 5 base 2 plus log 3 base 2. Let's see if this will give us 30 on the right hand side. Now, from one of the laws of indices, you know, if you have 2 raised to power a times 2 raised to power b, this can become what? 2 raised to power a plus b. So if you check, this and this have the same appearance, have the same form. But what I want to do is to transfer it from this form to this form. Let me show you. So this will become 2 raised to power 1 times 2 raised to power log 5 base 2 times 2 raised to power log 3 base 2. Because if you use the law of indices again, trust me, it's going to become, let me just clean this first. If you use the law of indices here, where you have the same base, see 2, 2, 2, you're going to add the exponent. And if you add the exponent, you're going to have this back as we had before. Does this make sense? I hope it does. So by testing if this will give us what? 30 on the right hand side. So we keep going. Now, from one law of logarithm, look at this. If you have a raised to power log, let's say 5 base, or let me just say log x base a, because the base of the logarithm matches with this general base a, because a and a are the same here, you can actually just get rid of them completely. Okay, so it's going to be, see, you can do this will cancel this, you just have x left. That's exactly what I'm going to be doing with what I have here. So see, let me just use another color, so I'll show you what I'm trying to say. So see, log base 2 will cancel this 2, log base 2 will cancel this 2, because the general base and the base of the log, they are the same. So I'm going to have 2 times, this is remaining 5 here, so 2 times 5, and times what? This is 3, so times 3. Let's see if this will give us what? 30. This is not decimal point, by the way, is times. So what is 2 times 5? That's 10. 10 times 3 is what? 30. So 30 is equal to 30, and hence the value of x is what we had before, which is what? This right here. This here. So this is the value of x. I hope this video was helpful. If it was, please like, share, and comment. Let me have your thoughts in the comment section. Don't forget to subscribe and share this video with your friends and family. Thank you. I'll see you in the next video. Bye for now.